So volcanism, definition of volcanism is it's a process of creation and movement of magma and associated eruptions and landforms. The sources are mostly mantle but can also be the crust. Plate tectonic theory explains the volcanism events and the locations where volcanism happens. Volcanism is integral to periodic process. For example, formation of the earth crust is explained through via volcanism. Volcanism results in formation of igneous rocks. To understand the composition of magma, Bowen has given his partial melting concept. He was a Canadian geophysicist. So the partial melting concept, the rocks, they are, as we have seen, they are mixtures of minerals. So they do not have definite chemical or physical properties. So when rocks are heated, different parts of the rock, they melt at different temperatures. So here we can see here, if we apply 1000 degrees centigrade and the melting points of different rocks are 200, 300, 700 degrees centigrade, when they come out of the vent, they first the C1 cools, then B, then A solidifies. So Bowen has studied all this, and he, according to him, the magma forms and moves, and the rocks solidify, and this rock solidification depends on two things: the temperature of magma and how the magma cools. That is it cooling inside the earth, the outside the earth, surface, all those things. So according to him, he has given this series, Bowen's partial melting series. Peridotite cools down as solidifies as basalt, basalt as andesite, and andesite as granite. So these are the minerals. This is not important. Now coming to the types of volcanoes, there are four types of volcanism. First one is volcanism mid-oceanic ridge. Here the peridotite from the mantle is coming out and undergoing partial melting, and it comes out as basaltic eruptions. We can see here, according to the Bowen series, peridotite becomes a basalt. Since basalt is very basic and fluidic, this will be quite volcanism without any destruction. Now volcanism at hotspot. Here these hotspots are interrupted volcanisms or standalone volcanism, therefore they are very deep, and they come from the core mantle boundary even. So these are very ultramafic peridotite unit, and they come out and undergo partial melting and form the very mafic form of basalt. Since this is very mafic form of basalt, it will be very quiet and very fluidic, therefore basaltic lava, it will spread as lava plateau. Example, Deccan lava plateau. Now coming to the third type, these are happening at ocean margins at trenches. Here we can see this ocean plate is subducting. Since ocean plate is made up of basalt, it will come out as undergo partial melting as the andesitic. Since andesite is acidic and viscous and thick, the eruptions will be very destructive, explosive, and strong earthquakes are associated. Even tsunamis can form and large scale destruction can happen. Therefore also these eruptions will form high volcanic peaks because the lava doesn't flow like the basalt. For example, Tonga Island. Now coming to the ocean continent collision, here we can see again the basaltic ocean is undergoing subduction, therefore it will result in andesitic volcanic mountains on the already Andes type of mountains. Also the old andesitic archipelago and the other sediments in the Malay, they will undergo the subduction, and since this is andesite, according to the Bowen series, it will turn into granite. But granite is very viscous and very thick and undergoes rapid solidification, therefore it won't be able to come up, therefore it will solidify within continents as batholith cores. So the andesitic eruptions, since they are already, we have seen, very viscous and very thick, these will be very destructive earthquakes and volcanoes, and also the batholith cores will form. These batholith cores, they form the basement rocks of the continents. They are fundamental to the continent formation. These large batholiths, several of them, they metamorphose and fuse and form something called as cratons, which are the fundamental building blocks of the continents. So we can say that continent formation happens at ocean continent collision. And coming to the third type, that is CC collision. We know there are no earthquakes or volcanism. There is no volcanism but only earthquakes here because no subduction is happening here. But volcanoes will be present because these are from the Andes type leftover mountains from the OC type collision. Also the remnants of the batholith core will be present in this. Now this is the Pacific Ring of Fire. We can see different type of trenches like Peru Chile Trench, Middle American Trench, Aleutian Coral, Japan, Philippines Trench, Mariana Trench, Java Trench, and Tonga Trench. So this is the region where there are two types, OC and CC, OC and O type of collision boundaries are present. Therefore 80 to 85% of the volcanism earthquakes events happen here. This is the Pacific Ring of Fire, we can see here. And coming to the types of intrusive landforms, we have the batholith, we have this is the main core we have seen already. The laccolith, it is dome shape and it has a conduit or pipe. And also the faccolith, it has the anticline and syncline. Lopolith is saucer shape, sill is horizontal, and dike is vertical. Whenever the dike comes out, it will be very resistant to the erosion. And also this is the stratovolcano volcano, the most common type of volcano. Stratovolcano because strat means layers, and it has several layers of the volcanic material, and this is a parasitic cone, therefore it is also a composite cone. Whenever the volcanic material comes out and it cools down as an extrusive landform, we have seen the formation of the lava plateau. So these are the intrusive landforms. Different types of extrusive landforms we have: fissure, shield volcano, dome volcano, ash cinder volcano, composite volcano, and caldera volcano. Shield volcano happens when there is basalt, and composite and this type happens when there is andesitic or rhyolitic type of features. And also pseudovolcanic features, examples are meteoritic crater and mud volcanoes. These are features that look like they happen because of volcano, but the source is something else. For example, meteoritic crater forms due to meteorite rather than the volcanic eruptions. Coming to next topic, which is mountain building. First, define the mountain. Mountain is any elevation on the earth's surface with elevation greater than 1000 meters. If the elevation is less than 1000 meters, it will be called as hill or hillock or knoll. Now, based on the basis of origin, there are four types of mountains, which are volcanic, block, fold, and escarpments. Escarpments is like the edge of the plateau, which will look like a mountain from the edge. Types of mountains we've seen by volcanic mountains. These are accumulations of volcanic material, which is lava and pyroclast. Pyroclast is mixture of all the substances, and these are best associated with andesitic eruptions, because if there is basalt, it will form the shield or dome type, which will be very extrusive. They may be called as the plateaus. So the most type of common type of volcano is stratovolcano or composite volcano, which has several different layers of the volcanic matter. Coming to the block mountains, these are elevations associated with relative vertical slippage of blocks. Here we can see there's a rift here. Due to some forces or movements, one of the block will move up, or this block will move up, that will result in a certain elevation. This will be called as a block mountain. The falls here form due to the deforming forces, which can be of tectonic origin. Now coming to the fold mountains, these are very extensive, so they are very tall and very long chains. These are series of parallel ranges. They have marine sediments because of melange and accretionary prisms. Also, they are unique to earth. We can see some of the fold mountains: Rockies, Andes, Appalachians, Pyrenees, Cholan, Alps, Pyrenees, Caucasus, Himalaya system, Aravalli, Eastern Ghats, Urals, Atlas, and Great Dividing Range. These are some of the fold mountains. Now coming to theories about the mountain building. One of the earliest theories was given by Harold Jeffrey, who said that mountains are like wrinkles on the earth's surface. Fold mountains are like any other mountains. So all the mountains are like wrinkles on the earth's surface. We can draw a corollary with the milk cream here. The second one is given by Taylor. We have seen this already. Transition mountains. He explains that Laurasia and Gondwana come together, and this sea is compressed, and it is the marine sediments are compressed, and it formed the east-west transition mountains. So the precise mechanism, as we've seen, is wrong given by him. Back then, he explained fold mountains because of the sea scraping the seam ocean floor. Therefore, sediments they accumulated at the edge of the continent, as we've seen the northern and the western edges, because the continents move north and westwards. So, but this does not explain why the fold mountains are in the continent interiors away from the ocean margin. Example are Himalayas and Urals. Anyway, CLC theory is discredited. Therefore, this entire Wegener theory is wrong. Now, coming to the geosyncline concept in mountain building, this is one of the very old concept. It has been mountain studies for quite some time.